this episode of Jesters Garage, I'm visiting Andy Heitmann, owner of Hell's Gate Hot Rods. And he's going to give us a rundown on designing a chassis for Rick House's 38 Chevy Coupe, his high school hot rod, a car he's had for well over 50 years. Grab a seat and watch Andy toss and turn this virtual model on Fusion of a killer chassis, right here on Jesters Garage.
So the first part we do is take the scan data like we talked about before from the vehicle.
Underneath it.
Yeah, and so for here it shows instance the original frame. So I can isolate that and say that's how I would start.
So that original frame was actually fairly wide, wasn't it?
Yeah.
And then he had narrowed it in the back and pushed it in. Right?
Exactly, yeah. So yeah, it would have been, so this was not even really the original frame. This is like what he had modified in the original frame.
Right.
Yeah, like you said, he had back halfed it basically,
Yep.
you know, back in the day to get, so then we take all that data, wheelbase and everything, and we kind of figure out, okay, where do things need to be, where the tires, you know, the stance and all that into account. And then we went as far as putting his engine into the car. We'd already done the firewall.
And you scanned that engine, is that what you did?
Yeah.
So when you say you put it in virtually?
Well,
or did you put it in?
No, we put it in physically.
Oh, okay.
And made it fit because we did it while we were doing the firewall.
Oh, I see.
And we were doing all those mods
Okay.
already, so it's kind of like back and forth. And we put it in there and said, well, this is where the engine can live.
Right.
And where it fits nice, visually, aesthetically, and everything. And then we'll make sure we have no interference with the suspension.
And it was sitting, and the car was sitting on the original frame at the time.
Correct. Yep. So we have these different versions. You know, there's the body.
Mm-hmm.
We didn't worry about the top at that point.
Of course not.
Yeah.
It's going to get changed anyway.
Exactly. So, you know, we have all this data. We can actually compile it all on top of each other, you know, and see where it all fits, and then start figuring out our chassis layout from there. So it's all very handy, and like even here's the wheels and tires, you know, so turning all that stuff on and seeing, okay, how's all the fitment, basically all the 3D scan tools is using as a fitment model.
Right.
We're not reverse engineering the body or the chassis or anything. We're just using it for fitment modeling and getting our points of basically our critical points. So here is our current layout of the chassis, kind of in mirror. So this goes through, and there's a bunch of renditions, you know, for us to get here.
Sure, absolutely.
You know, and figure it out like wheels and tires. So when we put the rear tire in there, you can see how little room there is between the chassis.
It's ridiculous.
And trying to fit everything in, it seems all simple, but when you get that so large of a rear tire, two of them in there, everything gets narrowed. And so on this,
very challenging.
Yeah, on this particular car, we decided to run continuous rails front to back, and then what I call outriggers, which we talked about before, to catch the middle of the body.
Right.
And so that, because of the horsepower, because of that running a one-piece rail, we don't have this segmented chassis.
Right.
It's not like middle portion, front portion, rear portion, trying to get it all welded together. It's 188 3/16 wall, 2 beam manual vent, front to rear, continuous. No rubs, no cuts, no nothing, and it's all designed that way. So then what we have to do is we have to figure out, okay, there's the rear end, there's the front end, and then work within the mandrel bending die limits of the bender.
Oh, yes.
And get the rail profile, and then figure out everything, you know, and kind of piece it all together. Then once we get the rail profile, then we can start piecing in all the other suspension components. Whether it's AR mounts, you know, and all that. But the rear turned out to be the fun part, as far as to try to get everything to fit in there and get a long coil over.
Right.
You know, like we talked about, that long suspension.
So you can use that really nice ride in the middle, and outside of that is all that extra that makes the center part of your ride very comfortable.
Exactly. Yep. And since it's, you know, just a live axle, straight axle rear end, you don't have the leverage, the motion ratio, and the leverage like you do in the front. It's just straight So you have to use a long coil to get that right. A lot of coils are like 3 inches of right height.
Yeah.
And so you got to stiffen them up and short spring, and it doesn't work as well. So we like to use a longer, and then just for fitment and everything on this one, using triangulated, because if you look in the rear, if I can scroll here right, you start trying to use a Watts link or a panhard. So if you get like this rear view look here, it gets way behind the rear end, and you get a bunch of leverage in all the bracketry, or it looks kind of ugly, and like it doesn't package very well. So then we worked on, with that rail profile, how do we get this upper bar and the link and everything to kind of look congruent, and that's a big deal with all my chassis stuff, is I want things to look purposeful and like all designed together, not just simple brackets, just kind of tack weld it all.
And isn't it true that when you have something that's symmetrical, it's a lot easier to make your exhaust symmetrical?
Yep, exactly. And so like on this one, you can see everything. Yeah, we tried to make everything as symmetrical as possible, and the exhaust cutouts. So we actually put in exhaust cutouts through the cross member with the driveline hoop, incorporated all into the design, and that's at that same location of where the outriggers go.
Right. So it's all tied together.
It's all tied together, so you get that that rigidity for torsional rigidity.
And you're designing one into the other before you even cut the first piece of metal.
Yep. All our fixtures, everything. Like everything is all designed, and actually you can see some of the fixtures here or there. I actually even have the chassis table modeled. If I can find it. So here's another thing. There's a driveline reference, so it doesn't move at the tail of transmission, and it moves 6.5 inches at the rear, and so you have this working envelope of the driveline. And so we model that, and then look in here at the driveline and look and see, like, does it clear? And so you can. It's hard to tell at this angle, but it barely clears both sides. And this is actually like a 4-inch diameter reference. Yes. The driveline won't be that big, but that gives us a little buffer. And so we can do all those checks. We can check steering, we can check everything, and make sure we don't have any clearance issues. And then we can just build it, laser cut everything out and build it. So then here's the chassis table. So like I said, I lay this out, and so for instance, like this chassis is laid out exactly 4 inches off the table.
Okay.
So it just makes it easy so that we can make all these fixtures and laser cut them. Everything drops in, everything stays level, and then we use other fixtures to locate suspension components as well. And so that we have right here, this holds the rear end, as well as the bracket for the forward link and the coil bracket. And like this fixture here, it holds the forward and aft location of the outrigger, butts up against there, which is level. It holds the forward link mount there, which is then radius to the mandrel bend. So if you pull this fixture off of the view, there you can see. And so that helps, so it's all designed for that mandrel bend radius. Once it's all welded in, it just looks like one congruent piece. And so there's a lot of time in the design that people don't realize.
Yeah, I understand that, because
how many
you
hundreds of
can
hours
just throw it out there and just like, hey, we'll design this.
Exactly.
It's a lot of work.
But then it's just like a puzzle. Everything goes together, and like we showed the tab and the slot, the drawings that we're making.
The more time you put in design, the less time there is out there.
Exactly.
That's the way it is in my world.
Yep, exactly. And the less issues you have coming, I didn't realize that interfered, or like now we have a problem. Like all that is, like we try to think ahead and get all that. I mean, we get most of them. We're not 100%.
It's hard to get them all.
You can't get them all, but you can get. This fixture locates here. Stiffener bars across. I even was able to get the entire power rack model from the company that makes the power steering rack, and so we have all that to model in there as well, and to do all that. And we can talk about it at some other point, but I do have some pretty proprietary stuff that we're working on for our front suspension on steering. And so we're gonna make machined all in-house and custom built where we can adjust bump steer on the fly at every vehicle. And so we can dial bump steer 100% out.
Wow.
And so the tie rods and steering will all be adjustable more than just standard Heitmann joints.
Right.
And so it's something that we're almost got it done and figured out, but it's a pretty complicated piece that we're gonna have to machine to make it all work. And then everything will be adjustable and get it all. So things like that is what we try to do. You know, everything is try to make as much as we can, just so we can control and we can make it, and it's not just like parts that are just bolt on.
Right.
You know, make them work, they're bolt on it, but it doesn't look like one open perfect piece.
Well, and a lot of suspensions, let's just say a Mustang 2, is designed for a Pinto, which was a fairly short wheelbase car, and you can put that in a car, street rod back in the day, and it would have been far better than the straight axle, but the Ackermans and all your roll centers was based on what Ford did for the Pinto, not what you would do for a 53 Chevy.
Exactly.
So you could put that in there, and yes, it'll work, but it's not even close to this level. Where what you're doing is you're taking everything into consideration, and you're working with all of those chassis handling numbers that people do when they're in the engineering part of this world, and you make it work per car.
Yep, exactly. And it might be little changes per car, but it still changes. I mean, wheels, like I said, wheels and tires, it's going to change strut radius.
Right.
You know, it's going to change Ackerman depending on track width, things like that. So there's things that we can adjust, and like even building our spindles ourselves, you know, we can adjust spindle inclination, distance between the upper and lower A-arms, so where we're at in the travel. And that's the biggest thing we see on like other OEM stuff that's modified is you're held within those bounds. Or like say, hey, you're going to use a Mustang 2 spindle or a Sonera spindle or whatever, then that you're kind of stuck.
Right.
Where we can start with a blank slate.
Right.
So
it's okay. There's so much grinding in my videos, but I'm learning to adjust. If you watch, if you watch the Chop Top video, there's a bunch of bloopers at the end. Rob's like, he's teasing Nate, and I'm just like, shut up, man.
Yeah.
it's
trying to film over here.
Yeah.
Yeah, exactly.
Give me 5 minutes. Next up on the Jesters Garage Rick House 38 Chevy Coupe series, I'll show the process how the crew at the Hell's Gate Hot Rods assembled this one-off amazing chassis. And following that, we'll cover the guys at the jalopy shop as they rebuild the floor, tub the rear, and completely rebuild the rear section of the body and fenders. Well, I hope you enjoyed these videos as much as I enjoy putting them out. Give us a thumbs up and a comment if you'd like. Subscribing's always good. And we'll see you next time right here at Jesters Garage. God bless.